All right. So we're going to start out with a pretty basic concept on a number line. We'll have 0 here in the middle. And this is 1, 2, 3. And then -1, -2, -3. All right. So if we look at the inequality, okay, of x is less than 2, okay? X is less than 2. How do we graph that? Well, first of all, we can recognize that x can be any number that's less than 2. So clearly -3, -2, anything off this way. But how far up does it go? Can x, this is the question we need to ask, can x be 2? And x cannot be 2. And so we're going to put an open circle at 2, and then we're going to fill in everything to the left. And that's how we graph that. Anything less than 2. Open circle means it can come all the way up to 2, but it can't be 2. Okay? And that's going to be different, let's say, from the graph. X is less than or equal to 2. Okay? X is less than or equal to 2. So if we have a graph, same numbers, 1, 2, 3, 4, -1, -2, -3, -4. Here, I can go all the way to 2, and I can be 2 because x is both less than and equal to 2. So that's going to be a filled-in circle and everything to the left. So notice the difference between these two graphs. In this case, I can have an open circle, and in this case, I can have a closed circle. What's the difference? Whether or not I'm equal to the number, right? Because if I had the statement x is equal to 2, and I had my graph here, I would have a dot at 2 because x is equal to 2. That's why a dot exists here where x is both less than and equal to 2. Now, always be careful when you're graphing these. It's very easy to confuse yourself. So for example, if I switch the x and the 2, right? The sign is the same. It's the exact same. But I'm saying something completely different here. I'm saying 2 is less than or equal to x. So what is x? X is actually greater than or equal to 2. So it can be 2, but x is greater than in this case. So it's going to open up to the right. Okay. Now, if you remember, we had several times where we would find two values for x. Let's say -1 and 3, right? -1 and 3. So what would this be with these types of brackets, these curly brackets? That means that it can be -1 or +3. Okay. But if we have the brackets like this, x is equal to -1 comma 3, open. Okay. We would have an open circle at -1, an open circle at -3, and everything in between it filled. Give you a second to write that down. And what that means is x can equal anything in between -1 and 3. That's what those open parentheses. Notice how that's different from these parentheses, these curly brackets that we've been using. That means that it is only -1 or 3. -1 or 3, nothing in between. But when I use these type of brackets, it means everything in between. So we'll look at another set like this. In fact, let me show it to you kind of side by side, or stacked up on top of each other, I should say. All right, so this one will be x is equal to, we'll use the curly brackets, -1 and +3. This one will be -1 and +3. We've already looked at those two. But then this one will be -1 and +3 with the square brackets. And then you have two that where you can kind of combine. So -1 and +3. -1 and +3. Okay. 0. And just for the sake of time, I'm only going to put -1 and +3 on each one of these. Obviously, we know the numbers 1 and 2 are in the middle here. And there's numbers below there, but just so we can kind of see what the different graphs look like. Okay. So in the case of the curly brackets, that means -1 or 3, nothing else. In this case of here, it cannot be -1 or 3. Those are the boundary points, but it is everything in between. Okay, we already looked at those two. Now, what do we mean by square brackets? Square brackets means it can be -1, and it can be 3, and it's everything in between. Okay, here, x cannot be -1, but it's still a boundary point. It can be -3, and everything in between. And then here, it can be -1, but this right here tells me it cannot be 3, but everything in between. Okay. Right. So the same thing with there are 3. And so the same thing with x is equal to 3, x is less than 3, x is greater than 3, x is less than or equal to 3, x is greater than or equal to 3. And then one more for good measure. 3 is greater than x. All right. So here this means x is 3, so it's 3 and no other number. X is less than 3, so it cannot equal 3, but it's any number less. Here x is greater than 3. It cannot be 3, so open circle, and then anything to the right, anything bigger. Here x is less than or equal to 3. So it can be equal to 3, and it's anything less than. Here, x is greater than or equal to 3. So again, it can be 3, and then anything greater than. Here, 3 is greater than x, or if we read it from right to left, x is less than 3. So it cannot be 3, and x is less. So notice it's the same as this right here. These two are the same. I've just switched the direction. And that's one area I wanted to show you that because that's an area where a lot of students get confused. Okay. Now let's look at what do we do when we have something like, let me, there we go. Okay. The number line, we're going to start kind of down this way. 5, 6, 7, 8, 10. Okay. And rather than having a simple x is greater than 9 or x is less than 9, we have an expression. 0 is less than -6 plus x. Okay, 0 is less than -6 plus x. So now I've got to figure out what is x to where it makes this inequality true. Notice I did not say the word equation. X such that this equation is true. That would be incorrect. There's no equation here. There's only an inequality. Okay. So we're going to solve this in the same way that we would solve if there was an equal sign there. But there are a few differences to pay attention to. So let's go ahead and set this up like normal. 0 is less than 6, -6, sorry, plus x. So I'm going to do the same thing I would do. I'm going to add 6 to both sides of my inequality. And that gives me 6 is less than -6 plus 6. That goes away, so I have x. So now I can actually put something there. X is greater than 6. Can't be equal to, so I use an open circle, and it's greater than 6. Okay? All right. Here's another one that we'll do. This one is going to have 0 in the middle. And this inequality is 8 is less than or equal to x plus 5. Okay, so I'm going to rewrite my inequality over here. 8 is less than or equal to x plus 5. And I'm going to subtract 5 from both sides. And that on this left is going to give me 3. And here's going to cancel. So 3 is less than or equal to x. So x is greater than or equal to 3. So it can be 3, and it's anything greater than. All right. Look at it's going to be 0, -1, -2, -3, -4, -5, -6, -7, -8. Okay. And the inequality is 12 times x is less than -48. All right. So I'm going to bring my inequality over here. I'm going to say 12x is less than -48. And I'm going to divide both sides by 12. X is less than -48 divided by 12 is -4. Okay, so x is less than -4. So an open circle at -4, since it's not equal to, and then anything less than, so to the left. Right, let's do another one. This one I'm going to have 0 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the inequality, whoops, is -11 x is less than -66. All right, here's where things are going to get a little bit different. So I'm going to rewrite this as normal. -11x is less than -66. And I'm going to divide both sides by -11. Now, anytime when we're dealing with an inequality, anytime that we either multiply or divide by a negative number, I have to switch the direction of the inequality. So instead of x is less than, I'm going to change it to x is greater than. Okay? And -66 divided by -11 is +6. Now notice here on the one before, I didn't change the direction, okay? Because I was, even though 48 was negative, I was dividing both sides by a positive number. The only time that we're going to switch the direction is if we are dividing by a negative number. or we are multiplying by a negative number. So here we had x is less than, now we're going to have x is greater than. And like we said before, negative 66 divided by negative 11 is positive 6. So x is greater than 6. So x cannot be 6, open circle, and everything greater than it. All right. This one here, we're going to start at 208, 209, 210, 211, 212, 213. And we have x divided by 14 is greater than or equal to 15. Okay, so I'm going to rewrite my inequality. X over 14 is greater than or equal to 15. And in order to solve for x, I'm going to multiply both sides by 14. Now I can divide by 1 over 14 on both sides if I wanted to, but that's essentially the same thing. So 14 over 14 cancel. I'm left with x is greater than or equal to, I am not multiplying or dividing by a negative number. Now I just have to do 15 times 14, and that's going to be 5 times 4 is 20, 10 times 10 is 100. That's 210. And x is greater than or equal to 210. So here's 210. It can be 210, so close circle. And x, of course, is greater, so it goes off to the right. Right. Okay. So now let's increase the complexity just slightly more. And we can work on two-step inequalities. Okay. I'm going to have a line here. This is going to start here in the middle at negative 10. We're going to go up by 2, negative 8, negative 6, negative 12, negative 14, negative 16. All right. And we're going to have negative 14 greater than or equal to 7 times the quantity x plus 8. Okay. So here, what I'm going to do is rewrite my inequality. Negative 14 greater than or equal to 7 times the quantity x plus 8. And here I'm going to solve the inequality. So I'm going to take my 7 and distribute it through. So that gives me negative 14 greater than or equal to 7x plus 56. Now I'm going to subtract 56 from both sides of my inequality. That's going to be 70. Negative 70. Now notice I subtracted, so I have a negative sign, but it's not multiplying. It's not dividing. So I'm not changing my sign. My sign stays the same. Greater than or equal to 7x. Divide both sides by 7. Negative 70 divided by 7 is negative 10. Negative 10 is greater than or equal to x. So x is less than or equal to negative 10. So it can be equal to negative 10. And x is less than or equal to that. So it's anything off to the left. Right. Let's do another one like that. Here is the line. This one's going to have 10 on this side. We're going to go up. Negative 7 times the quantity 2 plus r is less than or equal to negative 19. All right, so I'm going to go ahead and write this off to the side. Actually, I'm going to write it here underneath. I'll need some space. Negative 7 times 2 plus r less than or equal to negative 19. We're going to be graphing r. All right, so I'm going to multiply through my negative 7 first. Negative 7 times 2 is negative 14. Negative 7 times r is negative 7 times r. And this is less than or equal to negative 119. I'm going to add 14 to both sides. And do away there. Gonna add here with my calculator. That gives me negative 105. Then divide both sides by negative. I'm dividing by a negative, so that means that I'm going to switch this r is less than or equal to r is greater than or equal to. And I'm going to take that negative 105 and divide by 7. I forgot I'm not supposed to use a calculator. So we'll do it over here. Negative 105 divided by negative 7. Negative 7 goes into 10 once. We'll take the negatives off for now. We know that a negative divided by negative is going to give me a positive, so we're just worried about the number. 1 times 7 is 7. 7 is 3. Bring down the 5. 7 goes into 35 5 times, so that's 15. Yep. All right. Okay, so R is greater than or equal to 15. So that means up here, I can be 15 and anything greater than 15.